In this video, I'm going to walk you through the lab materials for Lab 3, which is on textures. Okay, so what I've already done is I've already downloaded and built the project files. So if I go over to Xcode, obviously I'm on a Mac, but it should be similar for on Windows. So what I'm going to do is just build and run this code just to show you, but we should be presented with the blue triangle, the red triangle, which we did in Lab 2. Okay, so what we're going to be doing in this lab is apply a texture map instead of colors to our triangle. Okay, and what a texture map is just an image which we can map on to our a polygon within our application. Okay, so if you look at this triangle here, so we saw from the last lab that the triangles are defined by vertices. Okay, in a texture map we have corresponding vertices within our texture. Now the texture is, instead of having x and y, we have u and v coordinates. Okay, and u and v both go between 0 and 1. Okay, so this is our texture. So first thing we need to do is load in our texture. So if I go back to Xcode, I just want to show you that we have a texture class within this project, and in the texture class we have a function called loadBMPCustom, and all this does is loads in a bitmap file, and bitmap is an image file. Okay, so if I scroll down here, okay, so what I'm going to do is, after we created our vertex buffer object, I'm going to load in our texture. Now this crate.bmp, if I just bring up a file browser and go to the source folder, as you can see, crate.bmp is a picture of a wooden crate. Okay, so that's what we're going to apply to our triangle. Okay, so that's the first thing, load in our texture map, and this loads it into this texture now is going to be referred to by an integer texture1. Okay, now I'm going to introduce you to uniforms now. Within our shaders, our vertex and fragment shader, anything which is the same for all fragments of a triangle, we're going to call a uniform. And so rather than passing in that data from the vertex shader, we're going to pass it straight to the fragment shader. Okay, so here, first thing we need to do is get a handle for our texture sampler uniform. So what we have here is, I'm going to call my uniform texture1 sampler, and this is just an integer, and we use the command gl get uniform location to actually refer to where this uniform is going to be stored in the memory. Okay, so what we need to do is, after we've loaded in texture, I need to find out where this uniform is going to be stored in the memory by OpenGL. Okay, now I need to change the vertex shader. I'm just going to copy this code here, and I'm going to go back to Xcode, and same as what we did for lab 2, I'm going to create a shader program. I'm going to call it texture vertex shader actually I'm going to change the file extension in a moment. Okay, so now I'm going to change that file extension. Don't know why it's gone black, but hopefully that's worked, and I'm pasting that code in there. Okay, so what we have here is we have our vertex position, which is going to be loaded into our attribute 0, and we also have what we call vertex UV, which is going to be loaded into attribute 1. Now, unlike vertex position, vertex UV is a 2-element vector, which is just going to be our u and v coordinates. So if I just scroll back up, so remember our texture map is a 2D texture map, and it has u and v coordinates. Okay, we're going to output, well, the vertex shader always output GL position. Okay, that's by default, and we're also going to output our UV coordinates for our vertex. Okay, so that's vertex shader. Now for the fragment shader, so I do the same thing again. I create a file, and I'm going to call it texture fragment shader, And again, I'm going to save that in the source directory, and I've also got to change the extension. It's hard to see here, don't know why Xcode does that, and I'm going to paste in the code. Okay, so this is our fragment shader. So we outputted GL position and UV. So GL position gets inputted to the fragment shader, so we don't have to explicitly state that. But for UV, we have to say, okay, we're going to be inputting a 2D, two element vector UV. Our output color is going to be the color of the fragment. And this is the uniform which I mentioned earlier. Now, a uniform is something that is the same for all fragments in the mesh or in the triangle. This uniform, this is a type. So this says we have a sampler 2D, so a 2D texture sampler. And this texture1 sampler, this is what I called the uniform here in our main.cpp file. Okay, so if I change that name there, I could call it something different. I'd have to change this here. Okay, now our color of our fragment, okay, this is going to come from the texture. Okay, so this command texture, this is a GLSL command to say, okay, we want to take the color from our texture map or our texture sampler associated with the coordinates in UV. And this .rgb just means only take the red, green and blue color components. Okay, so that's our vertex shader and fragment shader. I've just noticed, but I think that's probably the file name is going to be a bit wrong. I'm just going to check. Okay, so that's our simple one. Okay, just checking our file names are correct here. Okay, and we've changed our shaders, so we also need to change or tell where we load our shaders or where we compile them. We're not compiling simple vertex shader anymore. We're going to compile texture vertex shader and texture fragment shader. Okay. So now, we sorted out our shaders. We've loaded in our texture, but now we need to specify the texture coordinates. And we did this in the previous lab, in lab 2, with colors. But now what we're going to do is we're going to define our UV coordinates. Okay, so here, for every vertex within our vertices array, I have a corresponding texture coordinates. Okay, so for the bottom left vertex of our triangle, that's going to correspond to texture coordinates 0, 0, which is the bottom left of the texture. The bottom right coordinates are going to correspond to UV coordinates 1, 0, which is the bottom right of a texture, and our 0, half, 0, so that's the top vertex of a triangle, and that's going to correspond to 0.5 and 1. Okay, so for each vertex we just have two coordinates, and I've created a texture buffer in the same way as I created the vertex buffer. You see these two are quite similar. Okay, so now we need to send the texture to OpenGL. Okay, so we've got to tell OpenGL what our texture looks like. So I'm going to do this within the render loop. Okay, so first command, GL active texture. Okay, this sets the current texture to GL texture 0. Okay, we can have up to 16 textures for a single shape. So the first one starts at texture 0. We bind the texture, so we say, okay, we've got a 2D texture, and I've called it texture 1. That texture 1 was what we called our create texture map. And then we create the uniform, so texture 1 ID. So this was the uniform handle, and we just got 0 there. Okay, so that's telling OpenGL what our texture looks like. And then we've got to send our UV texture buffer to the shader as well. So we did that with the vertex buffer here. So we've got to do the same with our texture buffer. So our vertex buffer is in attribute 0. Our UV buffer is going to be in attribute 1. Okay, so this attribute is 1. and we've only got 2 coordinates. So with our shape, we had our vertices, we had X, Y, Z coordinates, that was 3. Now we've only got U and V, so that's 2. Okay, and all the rest are the same. Okay, so if I compile and run that program, okay, so compile and run, and you can see instead of being red, we now have each of our fragments or pixels within our triangle comes from the from our texture map. Okay, so this works, but it kind of doesn't really look like a crate. So what I'm going to do is I'm going to draw 2 triangles to represent a rectangle. But before I do so, I just want to show you, if I change the vertices, okay, so our third vertex, which is currently at 0.5 and 1, I'm going to change that to 0.5, 0.5. Okay, so if I run that, replace. So what it's done is it changed the shape of our triangle, okay, but the vertex, the texture vertices are still, I think, still a half and 1. Okay, so this is still in the middle of the top edge of our texture map. So what I can do is I can change the texture coordinates so that that third vertex is at 1, 1. And if I run that, you can now see, but it's so this top vertex here is using the top right hand corner of our texture. So what I want to do is I want to add another triangle here to complete our rectangle. Okay, we saw in the last lab, in lab 2, how to draw multiple triangles. So what I'm going to do is I'm going to add this upper triangle here. Okay, so I'm just going to change the vertex and texture coordinates. So first I'm going to change the vertex positions. Okay, so that's my vertex positions. I'm going to change that. So we now have 2 triangles, and I'm also going to change the UV coordinates. So we now have corresponding texture coordinates. Okay, if I scroll down, just got to check. Yep, so this will update based on the size of our vertices. So if I compile, if I build that and run it, you can see I now have a texture mapped rectangle. Okay, so we've seen how to add a texture map to our shapes. What I'm going to just do now is actually talk a bit more about some of the options we can do with texture map. And the first one is wrapping. Now our texture coordinates were in the range 0 to 1, but if we specify texture coordinates outside that range, OpenGL will repeat the texture across the fragment. So what do I mean by this? So what I'm going to do is go back to our Xcode. I'm going to change the our texture map to be a smiley face. So I'm just going to change it here, smiley, and run that. Okay, so you can see I've now got a smiley face texture. Okay, so the texture coordinates were up here for between 0 and 1. What if I change this so it's between 0 and 3 for both U and V? I'm going to run that again. You can see what it's done is it's repeated the texture, and so this is for the default for our texture class. Now, if I go to our texture class, okay, if you scroll down, okay, so this is the bit which we're interested in. Okay, this is what's called the wrapping method. So here you can see we've asked OpenGL to repeat the texture map. Okay, so that just means if I go to the output, it just repeats the texture. We have other options. I'm just going to comment that out, and I'm going to ask it to mirror repeat, and let's see what effect that has. Okay, so I'm just going to build and run. Okay, so you can see here, if I take the bottom left texture, the next one across is a mirror image of that bottom left texture, and if I go up, the next one up is a mirror image. So each other one is a mirror image of the previous one. So that's something we can do. You could mirror repeat if you want to. Clamp to edge. if I show you what this one does, compile and run. Okay, so what that's done is that's repeated the texture. Now, in this particular one is a bit misleading because our edge pixels of our texture map are white, so it's just carried them on. So what I'm going to do is go back to that create texture to show you what it looks like. Where did I load it in? Down here, yeah. So I'm going to compile and run this. Okay, you can see the pixels right on the edge of the texture. They kind of been stretched out for the entirety of the shape where we don't have a texture. So that corner pixel there has been all over here. You may want that. To be honest, I can't think of where you'd want that effect, but you can do that if you want to. And the last one is clamp to border, which is perhaps the most boring one. Replace. Okay, so it just has it doesn't apply the texture at all. So it only applies the texture where it can, and where it's run out of textiles, it just doesn't do anything. Okay, I think for 99% of the time, you're going to just want the repeated texture map. So you might want to ask, why would you want to repeat the texture map? Well, if you've got a texture, for example, of a brick wall or a cobbled street or something, you can add if you think of a brick wall, brick patterns tend to repeat themselves. So rather than having a massive texture for a big wall, you could have quite a small texture and just repeat it. Okay. Now the other things we can do, if I go back to the lab materials, so that's texture wrapping. Okay. The other thing is something called texture filtering. Now when the OpenGL gets the color for the texture map, what it does is, or we can choose how it gets that. So this little circle here, let's say these are 4 pixels in our texture map, and this little circle is our fragment position. Well, we can choose to take the color of the nearest textile as our fragment color. So you can see that color sample will just give us a blue color. The other thing we can do is we can interpolate. So here, this is our same fragment position, but what our color sample is a interpolation between based on how far the textile centers are from our fragment position, and this will give this color. Now this is particularly useful for where we got a small texture map. So this is using the nearest textile, and you can see it can give you a blocky appearance, whereas if we do it what's called linear interpolation, this gives us a much smoother appearance. If you wanted to change that, you can see we have GL linear here, or you can use the nearest. I don't think this would make much change to our texture map because ours is quite a high res texture. Yeah, no, so it hasn't actually made much change. What I am going to do is change all these 3s back to 1s. So if we had a smaller resolution texture, yeah, this texture is quite high res, so you can't really notice much change. But if you had a smaller resolution texture, you may notice blockiness, and that's where we use linear. And the final thing we can control is the use of bitmaps. Okay, so sometimes we don't want to use a high res texture map. We might want to use a lower resolution texture map. So for example, if your shape is quite small, you're not going to want to use a high resolution. So bitmaps are just repeated textures half the size, and OpenGL will calculate your bitmaps for you. So if I go to the texture command, where have we got that? Yeah. So if I just undo that, okay, so you see this command generate bitmaps, and that's what OpenGL is doing. So it's essentially just copying and downsizing our texture maps. Okay, so I brushed over all that quite quickly. I'd advise you to go and read the lab materials for a bit more information. Okay, the last thing we're going to look at in this lab is the idea of having multiple textures on a single shape. And what I'm going to do is I'm going to add our smiley texture as well as our create texture. Okay, so where we loaded the create texture map, I've also loaded the smiley texture map. Okay, and notice I've called smiley texture 2. Okay, so I can't call it texture 1 because that's already taken. So first thing, loading the texture. Okay, again, so I'm repeating all the steps we did for the single texture. So get a uniform for our texture 2, which is the same as what we did before. Bind the texture. So our new texture, we need to bind it. And this time, I bound it to texture 1 rather than texture 0. Okay, so notice that's a 0 and that's a 1. So we've got an additional texture, so I bound it to GL texture 1 rather than GL texture 0. Okay, and we have to update our fragment shader to tell it that we're going to be using two textures. So I'm just going to replace that code. So the only changes which were made was we got an additional uniform, which is called texture2 sampler. And this code down here, we're going to be using the mix function. What this does is it mixes our two textures. So our first texture was texture 1. We've got our second texture, texture 2. And this 0.3 means 30% of the fragment color is going to come from the second texture. So if I run that, okay, and compile and run it, you can see that our rectangle now has a combination of those two textures. Okay, so if I wanted an equal 50-50 split, if I change that to 0.5, we can see the smiley face is a bit more prominent. Okay, so you might be wondering, why would we want to apply more than one texture map? Well, later on when we look at normal maps, which is to do with lighting, that's where we're going to apply more than one texture maps.